everyone, this is Sahiti. Today we are going to learn about one of the most important CPU scheduling algorithms, shortest job first, also called SJF. In this algorithm, the process that has the shortest burst time gets the CPU first. Since we are learning the non-preemptive version, which means once a process starts, it will run until it finishes. Let's understand it better with an example and a Python program. So I am using Programmize Online Compiler to run the code. So we will solve it by 7 steps. Within the 7 steps, we will get to know what is what and everything. So let's keep a heading. Is hashtag shortest job first. Nothing but SJF. And we are gonna do non-preemptive one scheduling. So now our first step is to define the process data, right? So each process has process ID, arrival time, and burst time. So we'll write step 1 as define process data. So now we know that each process has process ID and arrival time and burst time. So let's code that. So, so here we can see that each process has process ID, arrival time, and burst time. Therefore, I took processes as variable and I gave P1, P2, P3 as my process ID and 0 to 45 or the arrival time and 7414 or the burst times. So now let's move into the number of processes calculation. So now I'll keep a heading as number of processes. So we need to calculate the length of this processes. For that, PROCESSDS. So I'm calculating that. And this is length of processes. Let's enter into our step 2, which is sorting processes by arrival time. So that this ensures we always look at processes in the order they come. So this is step 2. So for that we are gonna sort using sort processes dot sort. Therefore key equals to lambda x to minus 1. Perfect. So this is sorting method. Now let's enter into the step 3, and our step 3 is initialize helper variables. Now time equals to 0. This is for tracking current CPU and completed. Next, waiting time. So it stores waiting time for each processes, and this completed I used to store executed process for Gantt chart, which we are gonna do later. Now turn around time Simple, it is same as it is as waiting time. Next, we are entering into the step 4. Step 4 is nothing but repeat until all processes are finished. So, yeah. So here we are using while condition, while process. So here we need to find all processes that have arrived up to the current time. So for that I am using available as variable. So P for P in process if P1 less than equals to time. Now inside while condition we are using if condition. Right. So if available. Now we need to pick the process with the shortest burst time. So we are gonna check which process is with the shortest burst time here. So I used current equals to mean available key equals to lambda. It's indexed. Now let's remove it from the process list. Since we are executing it now, we use process.remove method. Therefore, perfect. Now I'm gonna add extra details. So extra details. Therefore, PID, AT, BT. BT is nothing but burst time. So AT is nothing but arrival time. Therefore, start equals to time. Now finish equals to time plus BT. So yeah. Now let's record execution order for Gantt chart. So it's a completed dot append PID start finish method. Now we are gonna calculate turnaround time and waiting time. We all know that turnaround time equals to finish minus 80. 80 is arrival time. Now waiting time equals to turnaround time minus burst time. Next, turnaround underscore time PID equals to TAT which we obtained from the above line. Similarly, waiting time PID equals to WT. So we need to move the time forward. So time equals to finish. Hence we are concluding if condition over here, then we are calculating else. So now if no process has arrived at, just we need to increment the time. So I'm going to increment with time plus equals to 1. So now we are entering into the step 5 which is printing the Gantt chart. So let's print. So print in double quotes slash and Gantt chart for, and we are using for condition here for PID start finish in completed. That's it. Now we need to print time makers below the chart. So here I'm gonna print time makers below the chart using for condition same. Now we are entering into step 6 which is nothing but print results in table form. So here Printing results in table form, print slash and process time, next TIT, waiting time. So total turnaround time equals to 0, total waiting time equals to 0. Hence again we used here for condition. And the last and final one is the step 7, which is our final one, printing the average times. Hence this is the final code. So let's have a total look. Before that, I just I copied and pasting it. So let's see now. So this is the shortest job first non-preemptive scheduling. And step 1, this is defining the process data and we defined it, and calculating the number of length of processes, and next sorting this by the arrival time. So we sorted the processes by their arrival times. This means we keep in an order. Next, step 3, initialize helper variables. So step 4, repeating until all processes are finished. And stepping 5, printing our Gantt chart. And step 6, time makers below the chart, printing it. Step 6, results in the table form. Step 7 is printing the average times. And this is the full code. Let's run it. So this is how the shortest job first non-preemptive algorithm works. It gives the best average waiting time, but the drawback is that we must know the burst time in advance. So in this output, we got average turnaround time as 8 and average waiting time as 4. So then, which okay, we need to know the burst time in advance, which is not always possible in real time systems. I hope this code and explanation made the concept clear for you. Thank you.